Okay, we are now on page 3, number 11. A student has 5 motor vehicle accidents in 1 year and claims that having 5 accidents is not unusual. Use the frequency distribution below to determine if the student is correct. So one thing that we can do is we can go ahead and find the probability of having an accident. So remember, probability is how many times that event happens over the total. So what we'll need to do, we'll need to find the total here. So adding up all those numbers, and we would get that that total is 1,710. So the probability of having 5 accidents, let's see, 5, 45 out of 1,710. And let's go ahead and change that to a decimal. So using your calculators, 45 divided by 1710 would get us 0.026. Okay, so we talked about a while ago unusual z-scores, unusual probabilities, okay, as a decimal. Decimals for probability, answers for probability range from 0 to 1. And those unusual numbers are from 0.05 to 0, okay? This area right here is unusual. And sorry, not 0.05, 0.5, my bad. 0.5 to 0. No. Don't listen to me again. 0.05, that is correct. 0.05. 0.5, that'd be in the middle, okay? No. Okay, so 0.05 to 0, that is unusual. 0.026, that would fall right there in the middle, somewhere in this unusual range. So this is unusual. So this right here is an unusual percentage, probability. So then this answer would be, this is unusual. Okay, this is unusual. Again, it is probability, the unusual area is from 0 to 0.05, not 0.5. My bad on that. Okay. That was number 11. Number 12, the random variable x represents the number of credit cards that adults have along with corresponding probabilities. Find the mean and standard deviation. Okay, so to find the mean of this data, what we can go ahead and do is we can use our calculators for all of this. What we're going to do, we'll go into stat edit. So first thing, stat button, and we are going to edit. Okay, in list 1, we're going to put 0, 1, 2, 3, 4. And then over there in list 2, we're going to put what is underneath the P of X. Okay, so 0.07, 0.68, 0.21, 0.03, and 0.01. So put that in your calculators right now so that you can do this with me, okay, because I do have it in mind going through already. Okay, so now then, once you get those numbers in L1 and L2, we're going to go ahead and go second quit, and then, stat. This is step number 2, okay? We're going to go back to stat. We're going to go over to calc, and underneath calc, we are going to select number 1, the 1 VARS stats. Okay, then from there on this next page, or next screen, sorry, not next page, next screen, it asks us for the list. That is what we put in L1. We need to make sure we have L1 there. And then the next thing is the freak. It says freak list. So that's the frequency list. Okay, that is what we put in L2. So we'll go L2. And on your calculators, that's L1 and L2, that's on number 1 and 2 down there at the bottom. So you have to press second and then those numbers because they're in blue on our calculators. Okay, list is L1, frequency list is L2, and then we can go ahead and calculate. So pressing enter. Okay, so once we press enter, you'll get your list of data sets that it gives you. And the two things that we are looking for this question, it asks us to find the mean and the standard deviation. I'm just going to put SD up here. So the mean on our calculators, remember, is always the X bar. So in this case, X bar is 1.23. And the standard deviation is our sigma. So the standard deviation is 0.66. Okay, so again, we were able to use our calculator on this whole question. And let's see those answer choices. 1.23 for the mean and 0.66. That matches with answer choice B. I guess all that should have been circled, but okay, so mean, standard deviation using our calculator. So make sure you have your calculators for your exam coming up. Okay, next one, number 13. Find the probability of Z occurring in the indicated region. So now we moved from area to probability. Those two things are calculated the exact same way. So probability is the same thing as finding area. Because doesn't this bell curve that is drawn for you, it looks like what we draw whenever we are finding the area from a Z-score. Okay, so again, we go to our normal CDF. And we've put in our lower bound, which in this case is that negative 10,000. And our upper bound, which is 1.82. And we find, again, this is probability now, so that the probability, I'm just going to put probability equals, and again, rounding to 4 decimal places, 0.9656. 0.9656. So this looks like answer choice D. Area and probability, again, same thing, calculated with our calculators. Okay, last question on this page, question number 14. Assume that the random variable X is normally distributed with a mean mu equals 70, a standard deviation where sigma equals 16. Compute the probability that probability X is less than 90. Okay, so finding the probability, well, we got to somehow get to this point where we can put in our lower bound and upper bound. So first thing that we need to do is we actually need to compute our Z-score. Okay, so remember, to find that Z-score, we have our formula, Z equals X minus mu divided by sigma. Okay, so plugging in what we know, our X value was from our probability statement, which is 90, minus mu, which is 70, divided by sigma, which is 16. So 90 minus 70, that's 20 divided by 16, that's going to be what, 1.25? So our Z value is 1.25. So we can go ahead and we can change our probability statement now to be the probability that z is less than 1.25. So we can go ahead and draw our bell curve so we see that what we are doing visually. Make sure you do draw this, especially since this one, no, it's not multiple choice yet, but it's really good to draw this out just in case he does want this. So the probability that z is less than, so there's 0, 1.25 is somewheres over there. So less than, that means we are shading to the left. So then our lower bound is negative 10,000. Upper bound is 1.25. And again, we are using our normal CDF on our calculators to calculate this. And we would get that our probability that x is less than 90, the probability that x is less than 90 is going to be 0.8944. 0.8944. The probability that x is less than 90 for this situation, so it looks like that is answer choice C. That was page 3.